This conference will now be recorded.
Very good evening, students. So far we had learned about the concept of parallel plate capacitor, and if you remember, we had discussed in the previous class about parallel plate capacitor, where we had uh, calculated capacitance with dielectric and without dielectric. So without dielectric, if you have only air or vacuum, so in that case, dielectric constant is epsilon naught. Okay, this is dielectric constant. And if you remember, the area of cross section of the plates were A and the separation between the plates were D. In that case, we denoted the capacitance of the capacitor. This is sometimes called air capacitor also. So the capacitance for an air capacitor is epsilon naught A by D. So this is the capacitance of the parallel plate capacitor with air in between the plates. Now, if there is a dielectric material, a slab of dielectric constant K, suppose the slab has thickness same as D. I'm just, for the sake of understanding, I'm just drawing the slab little bit less thicker, but you just think that this has dielectric constant K and it is covering the whole space between the plates. So in this case, the capacitance of the capacitor will be C prime, or C we can write. So that is actually K epsilon, see K will be multiplied here. So K epsilon naught A by D. So this is what we had learned. And few more things we'll just recap. So this is one, this is case second. So case 3 was something like this. Suppose the parallel plate capacitor having the same like dimensions of the plates are the same. The area of cross section is A. Area of cross section is A. And separation is D. But now this time suppose the capacitor, say the space between the plate, see some T thickness is filled with a material, dielectric material having dielectric constant K, and rest of the place is air again. So in this case, what will be the formula for dielectric constant? The formula for capacitance. Formula for capacitance will be, suppose this is C double prime. So this will be written as epsilon 0 A divided by D minus T, D minus T plus this is T by K. Okay, this is the formula. Now if suppose this space, I can come here for fourth case. Suppose the space between the the plates is filled with n numbers of dielectric materials, okay, dielectric slabs, n number of dielectric slabs, and each having thickness T1, T2, like that it goes up to Tn, okay, and the dielectric constant of the slabs are K1, K2, like that it goes up to Kn. So if this is the case, then what will be the formula? See here, we can just write here C triple prime, say epsilon naught A. See here, now there is nothing called D. See, but still I'll write D minus T1 plus T2 plus it goes up to dot 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 Tn, and the other term, this one, will be written as T1 by K1 plus T2 by K2, and like that it goes up to Tn by Kn. Okay, Tn by Kn, and by default I have taken all of them has the same area of cross section A. So you can see here, so this D and this T1 plus T2 plus T3 up to N, this thickness is actually the same D. So this term will be getting cancelled. I hope you have understood this. Last time also we had discussed this. So D is equal to T1 plus T2 plus thickness T3, like that it goes up to Tn. So this is the total thickness D. So this term will be totally cancelled. So this term will be totally cancelled and the other term will be remaining. So what is that term? So for N, sorry. See, it will be only T1 by K1 plus T2 by K2 plus dot dot, it goes up to N, Tn by K. So this is actually the thing we had already discussed. Okay, so today we'll be actually solving few numerical problems based on these concepts. Okay, so we have to remember what is the formula for capacitance for an air capacitor when a dielectric slab is inserted in that. Okay, when partially it is filled with some dielectric material, when it is totally filled with like different dielectric materials. So there are four cases as such we had discussed, and we'll see there are few more things which we had discussed. Those will be recapitulated when we go ahead with the numerical problems. So I'll clean everything as and when required. I'll write the formula again. So first problem is this one. See, here I have got a very nice problem for you. See, the question says find the ratio of capacitance of the capacitor filled with two dielectric of same dimension but different dielectric constants K1 and K2 respectively. If K1 is equal to 2 and K2 is equal to 3 respectively, then what is the numerical value of this ratio? This is what is the question we have to solve now. So to solve this problem, we can see we cannot directly write the formula itself of whatever we have got. So here sometimes we have to go with the basic knowledge, okay, or basic understanding of the problem. So what is the basic understanding of the problem here? We have to see how the dielectric materials are inserted. Okay, see in this case it is said that, see, you can see from this figure, say suppose this is figure A and this is figure B. So I have case A and case B. There are two different cases. So case A, in case A, you look this dielectric materials K with dielectric constant K1 is having area just half the area of the plates, right? Half the area of the plates. And this guy also has half the area of the plates. But the thickness, or the, yes, thickness is D for both of them. Thickness is D for both of them. Now, one more thing we need to see whether, so in this case, what you have to do, you have to actually consider two capacitors. So this part alone will act as a capacitor, and other half also will act as another capacitor. Now, when you have two capacitors as a combination, you have to see what is the equivalent or the total capacitance. Total capacitance. For that case, we have already discussed, we have two different combinations. One is series combinations of capacitors, series combination, and another one is parallel combination. So series and parallel combinations we have to consider. So we cannot directly write the formula and get the answer. So suppose for the case A, here, see, I have potential difference across this is V. What about the potential difference across this? So for this also V. That means what? So in which case we have both. See, I have two capacitors. Look like this. I have two capacitors whose ends are having the same potential difference. Okay. So V potential difference, here also V potential difference. If I connect this to a battery. Okay. So what we get here, I have two capacitors having capacitance C1 and having capacitance C2. They are in parallel combination, right? So I have two capacitors here. For this, I can write this is an equivalent circuit diagram for this particular capacitor. Okay. So, so these are actually series, sorry, in parallel combination. So equivalent capacitance for this, suppose I'm writing this as C prime. So C prime will be C1 plus C2. And what is C1 and what is C2? We have to calculate. See, if I have a capacitor having like parallel plate capacitors having a dielectric constant inside. Okay, dielectric constant inside of capacitor, dielectric constant 2, dielectric material of dielectric constant K2. Then what will be the capacitance? Capacitance will be C is equal to K2 epsilon naught into A by D. So similar formula will just apply for this. See, there are two capacitors, and both cases we can write C1. See, in case of C1, we can write K1 epsilon naught A by 2. Here not A, because the area has been half by D. And for this part also, we can write the same thing, K2 epsilon naught A2 by 2 into D. So this will be actually the capacitance for this A. I'll just clean this portion and write nicely. So what we get? So we get epsilon naught A by 2D into K1 plus K2. So let us say this is CA for the problem A. That's what I am giving, CA. Now, what will be the equivalent capacitance, like equivalent circuit diagram for the case B? Okay, I have erased what is B. This is B. This is the case B. Look, in this case, what is going to happen? In this case, how do you calculate capacitance? Look, here, area are the same, but D has got reduced to half. But in this case, look, this portion is at different potential, and this portion is at another potential. So V1 and V2, that means, see, where potential gets like shared in series combination, right? In series combination, the total potential of the battery gets shared among two capacitors, C1 and C2. So in this case, this is the equivalent capacity, like circuit. Equivalent circuit we have got, right? So this is having D by 2 thickness, plus area is same for both of them. Now in this case also, what we can do, we can calculate the equivalent capacitance. Suppose this is CB, right? 1 over CB. So 1 over CB is equal to 1 over C1 plus 1 over C2 in this case. So what is C1 and C2? That we have to first find out. So C1 and C2, I'll just take two parallel plate capacitor having thickness D2 by 2 and dielectric constant K1 and K2 respectively. So C1, in this case, C1 will be K1 epsilon naught A by D by 2. That means, this will be 2K1 epsilon naught A by D. Okay. So similarly, C2 will be written 2K2 epsilon naught. So I can just directly write it here. So 1 over C1, that means D by 2K1 epsilon naught A plus D divided by 2K2 epsilon naught A. Okay, I'll write here instead. Okay, so D by 2K1 epsilon naught A plus D by 2K2 epsilon naught A. Okay, so here the problem, okay, let me just go it here. So for this is A and this is B. We have to actually get the ratio of the capacitance for the both arrangements. So the for the first case, what we had got here, let us say this is CA and this is epsilon 0 A by 2D into K1 plus K2. This is what we had got, and for this let us just write. So we had got C1 over CB, and that is equal to, you can see from here, D by 2 epsilon 0 A 1 over K1 plus 1 over K2. This is what we have got. Now we can just do a little bit of simplification here. So K1 plus K2 divided by K1 K2, and see we can write here CB as 2 epsilon naught A K1 K2 divided by K1 plus K2 K1 plus K2. So this is what we can write. Let me just do one thing. I'll write this part alone. K1 plus K2. This is the one. So we have got both the things. Now we have to take the ratio. So I can just write simply here CB is equal to 2 epsilon naught A K1 K2 divided by K1 plus K2. Okay, this is the one. So I'll just write the ratio here. So I have to find out what is the ratio C by CA by CB. Okay, first of all, we had been given K1 is equal to 2 and K2 is equal to 3. These are given, but better to always keep the formula in general form. Let me see in general form. So C is epsilon 0 A C divided by, okay, let me write, this is K1 plus K2 divided by 2D and CB. So this will be K1 plus K2 in the numerator divided by 2 epsilon naught A K1 K2. See, ultimately what we are getting, this term will get cancelled from each other, and obviously D will be here, D. So this D will go here. So this D will get cancelled. So this will be K1 plus K2 whole square divided by 4 K1 and K2. So this is actually the general formula. In this case we are getting, okay, we are getting general formula here. Now put K1 is equal to 2 and K2 is equal to 3. Then let us see what we get. So K1 and K2, we will put this divided by 4, 2 into 3. Okay, so this is actually 25 divided by 24. So this is actually the ratio. Okay, so students, I hope you have understood what I have done here. So I'll just recapitulate once. See here, I had to consider two capacitors, okay, which are in parallel combination because end of this dielectric material is same potential as this. Okay, all right. So ends are actually connected to the same battery. Both ends are connected to the same battery. So that's why they are in parallel combination. But in this case, you look, these are having, these are at different potential. Okay, V1 and V2. Okay, that's why they are series. They are considered as series combination. Okay, and then we have to calculate the equivalent capacitance according to our knowledge of series or parallel combinations of the capacitors. Okay, all right. So we'll move on to the next problem. We'll move on to the next problem. And okay, so here there is a nice problem. Let me first write down the question here. The question says, between the plates of a parallel plate capacitor, capacitor of area a copper plate, a copper plate sheath on a dielectric slab, on a dielectric slab of K is equal to 2 as shown in the figure. Find the equivalent capacitance of this arrangement. Question is find the so find the equivalent capacitance of this arrangement. So in this case, let me tell you one thing. The thickness of this is d by 3. This is also d by 3, equal thickness. And this is also d by 3. And
This conference will now be recorded.